Well, let me go ahead and start with, I'm just going to reshare some information with y'all with my PowerPoint on who we are and what we do. And let me pull this up. Oh, click share, Claire. So
There we go.
there we go. Everybody see that?
Mm-hmm.
Yeah.
Yay. All right, so once again, can everyone see that?
Yeah.
Yes.
Okay, super. I know Shayla is been around for some time, and Dr. Marcia, this is, I know we showed this before at the conference, but I just wanted to remind everyone who we are and what we do, and that we are here for you for any information in between these workshops. If you're looking for resources or need anything at all that we might could help you with, lesson plans, etc., resources that we could send you, then just contact myself or Patty. And that's our contact info there. And some of the other things that we can offer, in addition to these online workshops, hopefully we'll be able to start doing them in person this next year, as we've done in the past. And then, but we are available if you would like for us to Zoom in or team in to your school or with some other teachers at any time. You know, we can certainly do that, or talk with your students about careers, STEM careers, NASA careers, etc., and connect you with other teachers as well. We've always got NASA challenges and contests going on that NASA promotes through its NASA Express mail that you can find on their educator page and sign up for. It's a free service. Once a week they send you an email that talks about the new things going on with NASA. In fact, I got one this morning, or actually it came in late last night, that the SpaceX is launching the Dragon today at 11:39 from Kennedy Space Center. So hopefully the weather's as beautiful down there as it is here. And I'm sorry, I can't remember where you're located, but we do have STEM kits and books and things for checkout as well. And sets of classroom sets of books and things like that. So, and of course the STEM Academy there at the museum, which is our education programs. We serve pre-K through 12th grade students, and then of course teachers. And we have, that's a photo of the Eagle building with the F-15 and some of the students in the balcony looking over it. But we offer virtual field trips, and we do have some scholarship funds available, or, you know, through grants that will help pay for it. But we've got some really good, and they're based on grade levels, the science portion of it, but they're all STEM related. So they have a variety of things that they can offer. It includes a virtual tour of one of the hangars in the museum. And these are the contact names for the virtual field trips, Liz Skinner and Candy James, and that's their contact info. So just a brief overview of who we are and what we do, and that we're here for you. The end. Stop share.
Thank you.
I'm learning this as well. So anyway, so let's go ahead and let Dawn. Dawn Hardy is a second grade GTE teacher. She's been working with NASA education and learning from it for years and years. I know she's been with me for probably 12 years at least.
At least.
And prior to that, you were in Utah, I think you said, and you were so excited to find us. So she's been an integral part of not just attending workshops, but providing workshops as a presenter for us over the years. And she is one who thinks outside the box. She finds anything and everything to do with those second graders that I know she can help us all see how to do it with whatever grade we're teaching. So.
Yeah, I even figured out how to do the glider, the area of the glider, just squaring off so my kids can go and work area and perimeter. So I'm doing the glider from the other day too. So I'm like, yay, more math. So, so first, what grades everybody teach? Because I don't want to, I mean, I know Claire and Patty, but Shay, what grade are you teaching now? I forgot.
Well, I still do K through like K through, high school, but my focus, and especially when I do summer camps, has been elementary. So
Yeah.
I'll just say a range of elementary school.
Okay.
So when I do summer camp, so yeah.
And Dr. Mormon, what grade do you?
I have 8th grade, and then next year I'll be teaching AP Physics.
Oh, okay. So the stuff I'm showing you, you'll have to kick it up just a notch or two if you actually want to use it, but NASA has it available already. So you kind of just have to pull down their stuff and just adjust it slightly. So
Okay.
It'll be helpful. So
Yes.
let me get, oh, my PowerPoint moved. Okay. Come on. Oh, there we go. Try it again. Yay, did that go right? Yay. Okay, so the focus today is using science concepts to teach math. So math through science. One of the things I do in my classroom that people constantly ask about is doing the science during math time, because I'll have math scheduled, but we'll be doing a science experiment. Well, my focus is actually on teaching them how to do the math within that experiment, more so than the experiment. So they're picking up the science more incidentally than the math. The math is the focus of the lesson, and how do you do the math? So that's what this presentation is kind of going to be about. Newton's laws lend themselves beautifully to teaching various math concepts, even with my smaller kids. So with the first law, the law of inertia, objects at rest, stay at rest, objects in motion, stay in motion. I call it the inertia law. That way I can remember which one it is, just personally. I found a couple of video clips that I thought were just outstanding. And then they sent me a thing and said, you have a free trial for 30 days and then you have to pay for a subscription. So I am going to show them to you, because they are very good, but I just a word of warning, they want a subscription after a month. So it's going to come up like it's supposed to. Oh, it did. Can you see that? Yes. But can y'all see them? Did it show them to you? Okay, yeah. Awesome. This one, I'll play it just for a second. Oh, sorry. That's where I left off.
I'm not seeing it.
Okay. All right, let me stop screen share and try at a different angle. That actually was the third law anyway. All right, let me see. Now, start screen share again. Let's see if it'll work. All right. Okay, let's try it again. It may or may not let you see it.
All right,
okay.
I see it.
Okay. And
Yeah, I see it.
The audio is not working, but
yeah, I was kind of afraid of that it was going to try and do that, because it doesn't like that you've got camera working and video. However, the thing about these videos, and I included links so you can pull them up at any time you want to pull them up, is that they explain very simply and they show the experiment, and all of their experiments are made with just simple things like balloons and straws and just really little magnets, things that you already have in a classroom. So it was a good source of just a video clip for them to see. And if you want to do the experiments, you could. It has lesson plans with it. I wasn't real thrilled with the plan, the way it was written out, because it just, to me, it didn't appeal as a teacher to somebody. If I were looking for something in a hurry, that's not what I would have gone with. But the videos are very good, and it's something you can show the kids and then let them experiment with if you want to. Now, with the little kids, we would be measuring how far the balloons went. We would actually make the string longer so that it goes until it stops and things of that nature, and finding the difference, because we work with place value. So we would actually have them log how far it went the first time, how far the second, and let them run in a course and then figure out the difference between different people's work. You could take your best run and find out whose went longer and by how much. The other thing was with the potential and kinetic energy, the unbalanced forces is something that we get in with second grade, but we don't dwell on it. But in the higher levels, they do kind of need to understand that unbalanced does not mean off kilter. Unbalanced just means that right now something's moving in a direction because one force has more than the other. And so that's one of those things that the kids, sorry, I get nervous when nobody's talking to me and I can't see anybody. So sorry, guys.
I hear you. You sound beautiful.
Y'all gonna have to deal with my nervousness. Sorry, Shay, you know me. I get nervous, so. All right, there we go. All right, so Newton's second law, which is where the mass versus weight, actually that particular activity comes in. And that's just the greater the mass, the greater the force needed to move the object. And this is one of the really good NASA simple activities you can do, and you can do it with many, many grades. I've actually gone into the kindergarten classes and done it with their kids as a demonstration with big blocks for them to measure off counting blocks. So it's a great demonstration. So that's where I want to go now. And well, no, I'll skip it. And then Newton's third law, opposite reactions. I'm gonna come back to that. Okay, so the mass versus weight experiment is straight from NASA. You have the link so you can pull it up. And it has all the math across several grade levels. And basically what you do is you make the little cardboard card. And you just put a paper cup in it. I use condiment cups because I have a ton of those for science, because we have to make everything individual right now because of COVID. So I have tons of those. So we actually use those. And then you need pennies or whatever weights you have in your room. We use pennies because I have a scale and a digital scale, and they just put it on it and weigh it. So it's a great experiment. I also use balloon blowers. You could just use straws and let the kids blow it if you wanted to. The balloon blowers we just found was a good investment to have, just because you can keep the power consistent. And with older kids, you would want consistent power. The balloon blowers actually come in many of the science kits that the schools purchase. So, but the basic idea is that you set up straws, and I'm gonna show you pictures in just a second. You set up straws equally distanced apart. It does not have to be exact. I usually set up about every 2 centimeters with my kids. I tell them about every 2 centimeters. And we will do some skip counting. So if we start at 1, 2 more is 3, and we do a little bit of skip counting with that as well, just to keep them fresh on, you know, where they should be, because you can skip count by 2s and 3s starting at any number. So they line them up, and then you put the box on it. There we go. Okay, so this is what it kind of looks like once you set it up. I always put painter's tape on the table, because I find with the younger kids, it's not so much with the adults and the older kids as they do it, but with the younger kids, they're not good at figuring out where they started last time. Adults and older kids will keep the meter stick in place and not bump it, and things that little kids bounce on the tables and things and make it move. So it's just a little trick. If you teach younger kids, there's your trick. Put tape on the table so they line it up with the tape every time. And so, can you see my arrow?
Yes.
Okay. So once they line it up, you see the NASA logo right there? That's where you're putting your air. And it's lined up just right that if you blow it, it goes well. So once you blow or put air on this, once you put air on this, and see, I just have the balloon blowers. You push air. This was with 5 pennies, just demonstrating. Once you blow it, this is basically what happens is it rolls down. And you do have to have the straws. I've already experimented with that. You do have to use the straws. If you don't, it won't move. But you blow it and it rolls down. So then you can measure off how far from the edge did your little cart move. 72 centimeters. And so on the paperwork, there's a place for you to log your total mass, and then your first test with no pennies, second test, third test, then find the average. And I'll come back to that in a second. I don't have my kids find the average right off the bat. I have them do all the tests first. That way we can clean up and then work the math, because this is about the math, not about the science necessarily. The science they will get as part of it, but I'm teaching the math at this point. And so then the cup with 5 pennies in it, and then the cup with 10, and they run 3 tests. And I usually play them that video clip of NASA saying always run your tests more than once, because the first time might have been a fluke and it worked, and the next time you may blow up and cause problems. There's a little clip out there that they have for that. And I usually play that one before I start so that they get it. Patty, did you say something?
No, I was just saying that I just love that suggestion.
Yeah, it's just a cute little video, and it has a little astronaut going out without his tool, and he does his job and goes in, and the next time he hits it and he floats away because he forgets to clip, and just all kinds. It's just a cute little clip. It's buried in the eclipse now, which is an event horizon all its own. So I have them go ahead and run all the tests and get those done. And so if I'm working with small kids, I actually have redone this sheet for me personally, where it has the number of blocks. So let me go to that one. So if I'm working with younger kids, instead of measuring with centimeters, I actually use the Unifix cubes, and you can see them here. You just line them up along the meter stick, and I obviously would turn the meter stick over to the inside for this as well, so that they can see that the blocks are about 1 inch. And you lay the blocks out, and then you can count. For first grade, I actually would go 10, 20, 30, and that's actually 39 inches. But I would count those off, 30, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and do that together, so that they are getting both the inches and the centimeters. Now for my kids in second grade, we have to compare. So I actually have them lay out the blocks, the inch blocks and the centimeters. That's why it's laid out the way it is on this. And okay, we got 39 inches, but it's also, which isn't right because the cubes are turned wrong for the picture. Sorry, I did it in a hurry yesterday. When you lay it out, the inches and the centimeters, you've got a drastic difference between the two numbers. And that is one of the things that the kids have to figure out, is there's a reason that the numbers are different, because the spacing between the units are different. And for second grade, that is actually one of their standards, is to understand why they need more centimeters than they do inches to cover the same distance. And so by using the blocks, and I just realized I laid them wrong, and that's why the picture looks weird. But by using the blocks as well as the actual meter stick, they can compare the two right there face to face. Only turn your blocks the other way so they really are 1 inch. I did this during planning. We don't have much time. So anyway, but that's basically how you count that off. Now, if you're doing the older kids, I would actually have them keep track of the centimeters and look at the differences every time. You know, did it do more? What do you think caused that? And just have them thinking about it from the science perspective as you go. But once you, whoops, sorry, wrong way. Once you get your data down, then you find averages. Now, for the middle school kids, they should be able to average unless that's what you're teaching that day. If they can't, then there's your math lesson, teach them to average. For my kids and the younger kids, I actually have them take blocks. No matter what the numbers are here, take blocks and divide them between 3 circles. And sometimes you will have a little remainder to the side, like a remainder of 2 or a remainder of 1. But this gets that beginnings of division for the younger kids going on. Because if it moved 51 centimeters, then I can take 51 cubes and put 1 in one circle, 1 in the next circle, 1 in the next circle. All 51 are dispersed, and start teaching them how to divide, even if I have a remainder. And I go ahead and say, oh, we have 1 remaining or 2 remaining, so we don't have enough to fill the circles completely. And so they can get a pretty close average kinetically using just the blocks and fill that in, and they don't have to use calculators. And for the younger kids, they don't have to use math they're not ready for. Now, my second graders, some of them actually do 3rd to 4th grade math. They can actually find the average. They can actually add them up and find the average. But for the ones that can't, they can take all 3 sets of those blocks, put the blocks together, and then divide them out, and they can find the average without having to crunch the numbers on a level they're not ready for. With middle schoolers, they should be able to do it. One of the things I really like about this particular activity also is that once they find their average, they graph it on a bar graph. And you can literally see Newton's laws being proven by the distance that they move. Now, the first one, the 0 pennies, is a little tricky because there are other things that come into play there. The 0 pennies, you would think, would literally move as far as or farther than any of the others, but it doesn't. And the only thing I can think is it's because it is so light, it doesn't actually have enough mass to move the rollers. And so the 0 is a little bit tricky, but once they get to the 5 and the 10 and 15, you literally see that curving off of the distance it travels. It travels less and less every time on average because of Newton's laws. You need more mass, or more mass needs more power, and you're using the same power every time. So it literally shows it. And then they can pretty well, even in 2nd grade, can pretty well answer the questions. Depending on the level of kids, you may have to explain what the question is asking. But for your middle school and your high school kids, you can easily let them answer the questions. And they can also work with the fractional parts, like if we were only working with 1/3 of this, how much would that actually be? Or if we only traveled half the distance, you can work with the different numbers depending on what standard you're working that day. It has, there we go. Oh, lost it. So some of the other things that we do in conjunction with this, now granted for my younger kids, I alter it, is, and this is actually not NASA, this is available through Paper Roller Coasters. And I gave you the link so you can just pull it. One of the things to accelerate some of my kids we do is we actually use the 1/3, 2/3, and the whole, and run the time and the distance of marbles moving. And so we can change out the marbles, change the mass. So after we've done this and they figured out that the more mass takes more power, then we change over and start playing with the marbles a little bit, because you can get the little shooters and you get the smaller marbles, and the mass is very different. And you can weigh them, see the difference in the masses, and then work from there. I use Paper Roller Coasters because cardstock's cheap and I can get it from the county and I can use it. So one of the things you can do is calculating average speed. Well, yeah, that is science, but at the same time, if they can't do the math, then they're going to give up on the science. And that seems to be, when you talk to kids about why they were so excited about science and being in the science field when they were little, and suddenly they hit middle school and high school and they don't want to do science anymore. What you hear them say is, I couldn't do the math. And so by changing how we think about the math with the science and making the science kind of a general understanding we're learning as we're doing math, they start getting it and realizing that the two are connected and that math is the language of science, and they start picking up that math because it's hands-on. And so it's a little bit different twist on the thinking, but the kids get it. And suddenly they're not so scared of the math anymore. They want to do the math and they want to see what happens. Now, right now with my kids in particular, we're working through, they're doing what we're calling the Elf Escape, and they're doing a little roller coaster that's contained to the area of a piece of paper. And they're building up, and they're building with the paper roller coaster a little bit of the pieces in cups and paper plates and building a roller coaster. And one of my kids that's extremely intelligent and loves to code, but doesn't really like to sit and crunch numbers for math, said, you know, you said you were going to look at whose was the fastest, but I don't know how to do that. And I said, well, you know what? If you will get this completely done and get it ready, I will show you how to calculate the speed of your marble. Let me tell you, you've never seen such excitement. And that is hard math. Distance over time for a second grader is really complicated math. But yet, I have 5 boys who want to know it all. And then the girls were like, we're not going to be outdone. We're going to do it too. Next thing I know, I have 10 kids all wanting to know how to calculate the speed of the marble on their marble run to compare. So it's just a matter of getting them to not be spooked by the math and to realize that the math tells them something about the science that they love and not be afraid of it. And so with this particular experiment, we won't do this one for a while because they don't have fractions down yet. But this is a fractional part for middle school, high schoolers. And basically they're finding the distance of the 3 parts and then figuring out the total distance. They're also figuring out their speed as the angle changes. And you can do a little bit with those angles. For my kids, it was a little difficult to do that with. They could measure the angle, but then they weren't sure what they were seeing. But for a middle schooler who's already used to using the equipment and finding angles, and that they know that the angle of attack has something to do with the speeds along with the mass, that works better for them. So it's just good, strong math with a little bit of a science twist. For the younger kids, I've redone this page to make it a little more kid-friendly because this looks a little spooky to little kids. But they are allowed so many pieces. I give them a budget. When we actually build a real roller coaster, I give them a budget. And they have to come in under budget. It has to meet the height requirements and the speed requirements. And by then, they know how to calculate speed, basically. Not exactly precise, but pretty close. And so I changed this out because our standards, they're not supposed to have coins and dollar bills in the same symbol for second grade. So everything is either so many cents or so many dollars. So I changed it out, but they have to purchase their pieces. I also have them pay for their tape. They have to pay so much per inch of tape that they get, because second graders will waste an entire roll of duct tape just to make a toilet paper tube stand up. So they have to pay for their tape by the inch. And let me tell you, when they find out they can only afford 10 inches of tape, they get a little concerned, but they start conserving and they start learning how to barter, which comes into my social studies skills and other things. Excuse me, allergies. And so it's something else you can do that's just straight math. Counting coins is one of our standards, and counting money. And depending on where you're working decimal points in the higher elementary grades, you can easily use this as a calculating decimal points or figuring out adding and subtracting decimals, multiplying decimals, because if you need 6 sharp turns and instead of $1.25, your price is 3.33, how are you going to figure out 3 times 3.33? So the math is there, but it's done in such a way that it's fun because they actually get to build something they get to play with. So they don't argue with you about multiplying 900 times to get what they want, or calculating the price of things, or any number of other things that you're focusing on. This was the gentleman who made the paper roller coaster. This was his lesson. And so he has things like the reliability, you know, how well did it go? Did it run a 30 marble test? That kind of thing. Did it meet the height requirements? It had to be greater than 30 centimeters, but less than 100 centimeters. And actually this year I stepped up my kids a little bit and I added that in with mine. So it had to be within a range as well. And then they had to track the total length, which you have to figure out how you measure that. Now, with the older kids, you can actually figure out those curves exactly. With the younger kids, we use a tape measure because they're too young to really figure that out mathematically. But with your older kids, you could easily figure out that curve mathematically. The length of the tracks, you know, did you have at least one loop, things like that, they get extra points for, and then their total cost at the end, because what they budget and what they buy from you initially isn't necessarily what they end up with in the end. As they start engineering and building, they realize they need more of something and less of other things. And they will barter a little bit, but I have them go back and calculate according to the pieces that are actually on their roller coaster, how much their roller coaster actually cost. So they do have to give me a final analysis. And some of them find out it actually costs way more than they had in their budget. And they just manage to barter and take and swipe and all kinds of things that kids do. And in the end, they get busted on it because I'm like, but you only had $15 and you've got a $22 roller coaster. How did you do that? You know, oh, I must have grabbed an extra. Yeah. And sometimes I have them figure out which pieces are over budget. And what would you do if they went back and said, you know what, you've got to return those. What are you going to do now? And I don't actually make them do it, but it's funny to watch their faces when you go, but you've got to return those 2 slides and that curve because you didn't pay for those. And it's fun to watch their reaction, just playing around with them to figure that out. So this is also another one that you can do that goes right along with the mass versus weight rollers, is calculating the potential and kinetic energy. I don't do a lot of the higher level math, but it's a fitting math for middle school and high school. Even some of the upper elementary kids, if you're in a gifted class, they could handle this. Because you're just dealing with the mass of the marble, the acceleration and the height and that sort of thing. So, but if you're focusing on the math and they're actually just doing the actual activity, it makes that math fun. And that's kind of the whole idea, is to make the math fun. Because if they're enjoying what they're doing, they're not frustrated with, oh, another problem for figuring kinetic energy. They're looking at it going, oh, I get to drop the marble 150 times to test this theory out. And so it becomes fun. And when it's fun, they're going to do more work, honestly. So it's worth it. And that's kind of all I put together. I don't know where my time is on this, but let's see. Oh, I'm a little off. However, let me stop share and I will pull up the actual NASA. There it is. Where's my screen? Where did my screen share go? Okay, there it is. NASA actually has more than just the mass versus weight. For my kids, that's appropriate. However, they have stretching mass, and I'll pull that one up, where you actually measure off using juice pouches. But there again, it's a lot of math because you're having to measure the weight and how far it moved, and then you're having to answer questions and find differences and work with the math. And so, let me see if I can get it to go the other one without switching off again. Oh, yes, it worked. It also has accelerating. where you're looking at the drinking pouch and you're moving with normal acceleration. And there are videos of the astronauts doing these experiments as well. And the links are also on the same page. But when, I was trying to find the sheet, there it is. They actually have to run the test, find their average time, and then they're answering questions explaining what happened and why. So you're getting the math, but you're also getting the science. And then on every one of them, there's an explanation. It's geared for teachers. However, I usually use it with my kids and let them read it as one of my reading activities throughout the day that they will do to go with this. So I'm getting true STEM. I'm getting the reading in, but I'm also getting the math in and the science. Okay, and then it does have design your own experiment. I can honestly say I've never done that one. But I believe Belinda Songer, I believe she used it at one point with her, I want to say her 9th grade physics class, and she really liked it. With my kids, time is of the essence with that, and we just don't have the time. But she used it, so she would be a good resource to ask if you wanted to try it, how it went. Okay, okay, there we go. Oh, it didn't go to the video. Okay, it does have all the reading material, but where is it? There we go. It also I won't click it because I know y'all can't hear it when I play it, but it has all these great mass versus weight videos, and they're just small clips that the astronauts do. And I actually was going to play them, and y'all can't hear them. So, the links are included on the sheet, the link sheet, so you can pull them up and then watch them. You can watch them with the kids. They're all 2 to 3 minutes long. They're short, but they do a really good job exaggerating what we see on Earth for the kids to see. Okay. All right, y'all jump in because that's what I have.
Dawn, I love how you pointed out, the fact that some kids that seem to lose interest in science aren't really losing interest in science. It's just that they're afraid of the math, because I've seen that too, and that is such a good point.
Yeah, well, and and I teach kids in 2nd grade, and honestly, every kid in my class, just about with the exception of 1 or 2, come out saying, oh, I'm going to be a scientist, or I'm going to be an astrophysicist, or I'm going to do this, or I'm going to be a biologist. And by the time I see them again about middle school, they're, I think I'm just going to go work here. And it's because the math spooks them. So we need them to get that math and understand that you can do the math. It's the same thing you do in math class. It's just you're applying it to the science. And so by twisting that around and applying the science to the math lesson and making the math the lesson, but including the science, these kids will work forever. Yesterday, my kids wanting to know how to calculate the speed. You better believe I'm going to figure out a way for 2nd graders to calculate the speed of that marble moving by the time I'm back on Monday. I will have racked my brain and figured out how to do that, with those crazy little roller coasters they're making. I mean, and let me tell you, those are some crazy roller coasters because I limited their area for their base. And I don't usually do that, but I did for this. And let me tell you, they've got some crazy stuff going on. So how are we going to figure that out? How are we going to figure out the distance? Because they don't know the high level math where you can figure what the curve of something is. They don't really know that. So I'm going to have to figure out a way to do that. But the thing is, that's high level math. And yet I have 7-year-olds going, give it to me, I'll do it. When we do these, and I just mentioned averaging numbers, they go, what? Okay, but I'm taking the blocks from this test and the blocks from this test and the blocks from this test, combining them. I have a total of how many blocks? Count them up, write it out. Okay, now, in order to find the average, I've got to divide it by the number of times I ran the test. Pull those blocks out into 3 circles, and you've literally just divided, but you use blocks. So even with the little kids, we can make this math seem simple so that they get it in their heads. it's not as complex and as scary as it looks. And one of my favorite lines came from Frank Locke, as a matter of fact, in one of the classes. He's like, formulas should not be falling out of the ceiling and whacking them on the heads. They should know what the formulas are for. And I think if we would start thinking in terms of our math, it's the language we use in science, and start teaching our math so that they understand it applies to the science, I think we could do a lot more and get more kids to stop dropping out on us because the math suddenly becomes 10 problems on a page and I'm not real sure what I'm doing. And so I'm just going through the motions I've been taught, but I don't understand how that applies to life. And so I don't want to do this the rest of my life. And have them realize that that fun science they love, this is how you speak to other scientists about it. And so to me, that's just where we need to go with this.
Well,
That's what
I really love to watch your workshop, Dawn, because you do that. You make everything mesh together, including the reading component. So I love how you put all the things, all the key points in there and show how they all go along together. So I really enjoyed this. This is wonderful.
Well, thank you, because I wasn't sure about the time on Zoom with this because
No, that's fine. I mean,
you know,
and
I
the
used to teach
videos,
kids on.
because the audio wasn't working, I mean, it cut down
Yeah.
on a little bit of time, but that's fine because it was very informative.
But you do have all the video clips there, including the ones that are on my free trial. So you can pull them up and look at them and then get your own free trial so you can have it for 30 more days. So, yeah, I found those and thought they were really cute. And then I was like, $30 a month? I don't think so. No. So, yeah. But the same clips are also available through NASA. So you can go to the NASA e-clips and find just about, there'll be different clips, but they'll be the same thing. And then the PBS stuff, I forgot the guy's name, Claire.
Michael Kinley.
Yeah, Michael Kinley, the stuff he shared with us, you can also go on PBS and find a lot of those clips. They're just a little bit different. It just takes a little bit of time to find them. But you get good at that Google foo, you like Kung Fu with the Google, and you start figuring out how to find them quickly. You start figuring that out.
So Dawn,
Also found,
no, go ahead.
oh, I was just going to say, I also shared the same sentiment that this was very informative, even though I teach middle school and I'm going to teach high school, but the physics part of it, and it was very encouraging. You just said that the younger kids want to know this. And I was delighted to hear you saying, as a teacher, you're going to work on your off time to figure out how to answer that question for the child that wanted to know how to solve for speed. Because what I've found in teaching physics in and of itself is a scary word. And then when I tell them, but science loves math, and so I'm gonna have to teach you some math, I've lost them. So I always have to come around teaching physics through the back door, and as through a phenomena or a hook or whatever the new political word is now, you know, for them to say, oh my goodness, now I'll allow you to tell me more about these formulas, you know, and how it actually works. But I'm encouraged by you that there are still students out there that are inquisitive and that you're giving them what they want when they ask for it. And I'm trying to talk louder than my birds, because if I talk, they talk. Y'all
I can hear you fine.
Okay, because they're just like going on and on. Some of the things, because I give my students, have them design and create a Newton scooter. And everything that we do always has a kindness at the end. If you're going to learn something that will promote a kindness at the end of it. So they have to do it with recycled stuff, because you can't go out and buy anything. Something in your house you can create it with. But I found some of the things that you were showing in the labs, and I was trying to find the labs again, that I can further enhance what they do, you know, in their designing their Newton scooter. And in designing the scooter, they have to show at least one of those laws in it. And they can't use, to make the scooter move, which throws them for a minute, they can't use gravity and they can't use batteries. So they've got to get it moving from rest without gravity or batteries. That wigs them out for a good 50 minutes. You know, parents are emailing. I was like, well, if you calm down and just think, and then the ones that think just like you showed with the balloon going down the string,
Right.
that one, they start to think, maybe I could use a balloon, you know, or maybe I could create, somebody got an old fashioned mouse trap. And when they let the mouse trap go, it moved the way they configured it, you know, it moved it. So it just causes them to just think, you know, a little outside the box. But I did find some helpful things in what you had presented to just enhance that particular project. So I wanted to thank you for that. It was delightful. It was good.
Oh, awesome. Thank you. Claire, that design squad thing that I think Patty did the class on with the rubber band cars, was that you? Can't remember who did that. That might be something you want to look at and use as
No,
well.
that was Tom.
Oh,
Tom is
okay.
the one that did that with the cars.
Yeah, that one. That might be a good one you might want to do as well with your kids. It's Design Squad. I think it's not Design Squad partner with NASA. It's one of those.
It was, yeah. And it's probably amongst that, the resources from Michael Kinlan with GPB, but it's, yeah, if you Google Design Squad, it'll pop up, and it's a PBS Kids, and then it has an educators section and parent section and whatnot. And it has some amazing resources there and activities, all hands-on things. And then there were 2 or 3 guides on there that NASA partnered with NPR PBS to, because there used to be that, it was a TV show called Design Squad.
Yeah.
And so anyway, but it's got some really great stuff. It's got that's got the lander activity.
Yeah,
and
that's right.
the rubber band car and those things. So, but yeah, you know, everything that you were saying, Dawn, I was probably sitting here nodding my head going, yeah. And, but you know, it is that, I like the way you say that math is the language of science, because it is.
Yeah.
And, you know, I mean, from the beginning of time, every child, including myself, is in taking math and being in high school, algebra, geometry, and algebra 2 and whatnot. You're thinking, how am I going to use this the rest of my life? I mean, what am I going to do with this? Well, you know, as you get older, you do see how you use the math in your everyday life. But being able to experience it, and that's the whole thing behind the STEM and really teaching students. I mean, the world is integrated. It just is. You know, everything, if one thing's not working right, nothing else works. So there's my cuckoo clock to join your birds. I hope it doesn't set them off. You know, it's the math, the science, I think bringing in the literacy point, you know, I mean, that's so important, because if you can't do reading, writing, and arithmetic, it's
right.
You're not going to be able to do the science or the social studies or anything else. So it's so important for the students to experiment with what they're learning, because probably you can think of a percentage of your students that could sit there and listen and learn and take notes, and they learn in that manner. And then you've got as many or more that they can't sit still, and they've got to do something. They've got to be able to see how it works. You know, they got to do that hands-on component, and that's how they learn.
Yeah.
So,
well, and that's why with my kids, they will take it way farther than I had planned. You just got to be ready for that when they do. It's like the one wanting to know how to calculate his speed. Those kids will take it way farther than anything you could possibly plan. If you're ready for it, you just kick your next standard in. Oh, well, let me show you how to figure this out. Let me show you how to do that. Her cars, I was thinking about, because my daughter actually teaches high school physics. Well, when she can get kids to sign up for physics, because they don't want to sign up for physics, because guess what? They're scared of the math. And so when she can get them to sign up for physics, she actually took back the car. I made the car in the class with Tom, and I used it with my kids, and I will again when I can find a safe COVID spot for my kids to do it in. We're going to make the cars and let them find the difference in how far the car rolls. But see, our tiles on our floor are exactly 12 inches. So when my kids roll it down, and I have a number line on the side of the floor with painter tape that I put down and pull up, they let their cars go, and they will go 8, 10, 20 feet, some of them 30 and 40 feet. Okay, but how many squares is that? Times 12. And I start upping that math level and getting them to think fluently about that math. So your car only went 4 squares. So 4 times 12 is what? 48. So your car only went 48 inches? Oh, can you make adjustments? But one of the things I was thinking about for your high school kids is that ratio of the size of the wheel versus how far it goes, or the length of your rubber band. Those ratios, you could actually throw that in with the high school kids could handle that. My kids can't. We do well just to figure out we need something to grip the floor, but you know, because they're 7. But the thing is, you could actually do those ratios and things with your students, have them change out the bigger wheels versus the smaller wheels, because everything is cardboard. It's all recycled material, everything with it, except for maybe the straws and the tape and the rubber bands, which I throw bags of rubber bands when the warehouse has extra. I just go, send them my way. And they do. And the clerk calls and goes, hey, some reason the warehouse dumped off a box of rubber bands. Yay. Because once they're out of date, they can't use them to go out and into the schools, but we can use them for engineering. And if they break, we don't care. We throw them away. And so we get even recycled rubber bands from the warehouse. But a lot of that stuff's recycled. So you could actually do that, because all they would need is a cardboard box. And with so many people ordering their Christmas online, now's a really good time to get them to save those boxes to use. So that actually might be a really good one for your high school kids, because you could really get the math in with that. I really just do distance and differences and a little bit of multiplication. And actually a little bit of angles for the kids who can handle the angle if their car goes off track. I actually have them sit down and measure the angle of how far off it went, just to see what the difference of going at a 90-degree angle, or actually I guess it's 180 degrees straight, versus at a 45-degree angle, what happened to my distance when my car veered off to the side? Did I lose distance? Did I gain distance? That kind of thing. I actually had one that used Pythagorean theorem because he wanted to figure that out. But, you know, gifted kids, they're all over the place. Some of them they can't read 5 words, but they can do high school level math, or, you know, they read like a rock star, but yet they can't add 2 + 2. So gifted kids are all over the place. You just have to be ready. But that's one of the things too, that you could do that with yours as well, as work those angles in there too. So that would be a fun thing to do. So.
Yes, that sounds good. Thank you.
So, Shay, where are you?
Sorry, I hope I'm not being distracting. Am I being distracting?
No, not at all.
Okay, sorry. I'm at a birthday thing for a party for my daughter. Look, where's my, yeah, so see my daughter. Oh, you can't see her because, say hi.
Oh, hey, sweetie. Look at her. She's grown
So yeah, she has. So we're at a birthday party for her friend from school. And yeah, that's where, and I already had said yes, and then I forgot I wanted to do this. I was like, you know what? I'm gonna just do 2. Because I remember like a lot of the stuff when you did something similar, or I've been to something similar about incorporating math and science, or just kind of trying to combine subjects together as you're teaching them. So I was able to keep up for the most part. And plus this is recorded and the materials are gonna be provided, so I'm gonna be listening to it again.
Hey, I was hanging balloon lights in the hallway the other day, listening to the gliders thing with my phone, going, wait a minute, what's that?
Right, exactly. So you know, with virtual now, we can multitask, but I don't want to get in the habit of doing it, because I want to be able to have my undivided attention. But sometimes it just can't be helped, I guess.
Yep, sometimes just life.
Yeah.
So, well, that's all I have. So, unless you need, Claire, if you'll wait to send Dr. Morgan her file, I will pull up my file, the Design Squad thing, because I kept it on my computer, and I'll send that to you so you can send it to herself. And then she'll be able to see it without having to Google it.
Okay.
Oh, thank you so much. Thank you.
I use that, so I can send it to you, and you can just up the level. It'll be easy.
Thank
Yeah.
you so much. This was great.
All right. Thank you, Dr. Mormon and Shay, for joining us from the space station. It looks like you've been floating around up there.
I know, right? I'm just,
It did look like
It kind of fits, doesn't it?
Yeah. Anyway, but Dawn, thank you so much. That was really great. I mean,
yeah, that was good.
for this theater arts major, I mean, I get it.
It's really hard when you can't hear or see anybody. It's really tough.
it is.
But anyway, thanks again, Dawn. And yeah, whatever else you want to send to me that I can share, I'll just put it all together in a neat little package and make sure that everybody has it. So
Okay. Well, I think Shay was in the class with us that day, so you already have it, right?
Yes, I do. I have hey, go back. I have a lot of the stuff, but I am gonna probably watch it, and if I have any questions, I'll just email you.
That you know how to find me. So
yeah, and Dawn, I'll most likely include your contact info or whatever, so that if anybody does have questions or need anything else or bounce ideas around, we'll go from there. So
yeah, we like bouncing ideas.
yes. All right.
All righty.
Well, everyone have a wonderful weekend. I hope the weather's as good in everywhere else. It's beautiful here.
It's cold, but it's pretty.
Yeah,
It's cold
but
out
it's a
there.
beautiful day outside.
Merry Christmas to
Yeah.
everybody too.
Yes,
I know
Merry
that.
Christmas.
Same
Happy
Yes.
to
New Year, and we will see y'all again soon. And take care, everybody.
Bye.
you. Bye. Thank you.
Bye.
Bye.
Thank you.
you.
Bye.
Bye-bye.
Bye.
Bye.
Mommy, mommy.